I'm still grading your tests. So it will be finished grading by Wednesday. Yep, should be Wednesday. So there is something I need to announce. Some of you really got the check the email. So the first thing I need to announce is the time here. So the following 2 Wednesday, we will not meet in classroom. We're gonna meet via Zoom using the same link as the Monday class. Just the same link as you guys entering here. So just for this 2 Wednesday, this coming Wednesday and next Wednesday, we're gonna connect via Zoom. So it's no longer we don't meet in our classroom till the November 3rd, which is the following Wednesday. Then we will be meeting it back to our classroom. So right now, the first 2 weeks is Zoom. So we'll see what happens with the COVID-19 exposed. So I will figure out what's going on. It's not me, it's someone else. Okay. Would recommend you guys to go test it. So just go and test. If you feel something weird or something else, go test it. One thing is that this Thursday, this Friday, and the coming Monday, there is no class. Okay. This is for all North Hennepin students classes. So if you are, I know we don't meet on Thursday, Friday, but if you do meet Thursday, Friday with other classes at North Hennepin, we don't have class, we don't have school. Okay, so Thursday, Friday, and Monday. So we don't have school on Monday. So on a Monday, since you guys don't have school, I will post some videos. So make sure you watch the videos. It's very short, probably I will recommend it's probably like 10 or 15 minutes long videos. Please watch the videos. I will post it on that Monday. It's a short videos for it. So and then when we come back on the next following Wednesday, it's again back via Zoom. So we don't meet face to face. So again, 2 weeks, 2 Wednesday, we are gonna meet via Zoom here. Anyone have any questions here? Anyone have any questions? And on last Wednesday, you guys took the test and I give you guys the chapter 7 and chapter 8 package of notes, which is this fellow. So we're going to talk about this chapter 7, chapter 8. There is no homework due on this Wednesday. So there's no homework due this week. So this Wednesday is no homework. So your next homework is going to be on the following Wednesday, which is the October 27th. Your online homework 7.1 and 7.2 is due on these days. Okay, so 7.1 and 7.2 is due on the next Wednesday, October 27th. So there's no homework due on this week. Okay. So we're gonna start talking about chapter 7 and 8. So your next test, which is your finals, your final in this case will consist of the last 4 chapters, 7, 8, 9, and 10. So this is the last 4 chapters we left, and that will be your finals. It still looks very similar to your midterm, where it is the first 10 questions is multiple choice, and then the last 4 or 5 questions is open-ended. So it's very similar to the format of your midterm that you took on Wednesday. So the finals will be on Wednesday, the last day of class. I think it's the December 15 or something else. Check your syllabus. This is in December, somewhere in the middle of December. I think it's 15 or what's Wednesday of December, something. Let me check. December 15. Yep, it's going to be December 15 and it's going to be in class. So it's going to be back in class for your finals in this case. Okay, so it will consist of chapter 7, 8, 9, and 10. It will be same thing, 10 multiple choice question, and then around 5 open-ended questions around. Okay, and you got 2 hours, around 2 hours to do it. Okay, an hour and a half. What do we have last? An hour and a half, 2 hours? So around that, around an hour to 2 hours. Less than 2 hours. Okay. Anyone have any questions with the what we're supposed to do for the last half of the semester? Okay, so this is halfway there. No questions. So we're going to talk about chapter 7 here. So chapter 7, we talk about 7.1 and 7.2. So chapter 7, 8, 9, and 10, the last 4 chapters is what we call as an inferential statistics. Okay, so the last 4 chapters, 7, 8, 9, 10 is doing what we call as inferential statistics. What is an inferential statistic? Is we make predictions. Okay, so the last 4 chapters is where we will start making predictions. How do we make predictions? We always use the sample data, and we always want to predict the population parameter. Okay, so what I mean in this case is, for example, if I want to figure out what is the North Hennepin students, let's say, what is the height of all the North Hennepin students in our college, I don't have time to call 10,000 students, which is everyone. North Hennepin is around 10,000 students, the population. So I don't have the time to call 10,000 students and ask them how tall you are. So what do I do is I just get a sample, maybe 10,000. I probably do like 500 to 700 students, and I will call these 500 to 700 students and ask them how tall are them. That is the sample. And then once I figure out the height of all these 500, 700 students in the sample, I find the mean and all this, statistic that you found, that you learned in chapter 3. And then I will use this to predict what is the population parameter in this case. Okay, so what is the population for all the North Hennepin students? So always the prediction mix is from the sample. Okay. However, when you write it out as a population. So you don't use the word sample in it. So we always use the word population. Another keyword that we use for population is the word all. So sometimes we don't like to use the word population. So if you have the keyword all, it's also symbolized as population. So so make sure you guys, when you guys read the questions, especially the multiple choice, if they ask you to give me a result and the result have the word sample on it, don't pick that result because it's not what we talk about. There are 2 types of population parameter that we will learn in this case. We will talk about 7.1, which is the population proportion, and we will talk about 7.2, which is population mean. So when you look at 7.1, it's talking about population proportion, and then 7.2 is talking about population mean. Same thing with chapter 8. So if you will look at 8.2 is proportion, and then 8.3 is the population mean. Okay. The reason why we split this into 2 types of population here, one is proportion and mean, is because proportion is for categorical variables. Okay. And mean in this case is for quantitative variables. So a lot of students, when they do my finals, they will figure that you have to first thing figure out, are they mean, which is quantitative, or are they proportion, categorical variables? So a proportion is a fancy word for decimal. So proportion means decimal. So so this class we will use the word decimals, proportion in this case. But what does it mean? It means decimals. Okay. So so in chapter 7, we will do what we call as estimating the values. Okay. And in chapter 8, we will do hypothesis testing. Okay. So the whole chapter 7, we're doing estimated value, which is what we're going to do in today's class. And then when you look at chapter 8, we'll perform hypothesis testing. Hypothesis testing is a bit difficult because hypothesis testing is around 6 to 7 steps. So when you perform a hypothesis testing, you have to the test itself is a procedure itself. It's a 6 to 7 steps procedure. For the estimating values, it's quite straightforward, so you do not need to worry about this. Okay, so so we're going to concentrate on today on chapter 7.1, which is we will do the population proportion, estimating the population proportion. So again, the word proportion means decimals. Sometimes we use probability, sometimes we use percentage. They all means the same thing. So again, this type of questions in this section is for categorical variables. For example, will be like yes, no type. So if you have a questions that asks you, do you smoke? Do you have this? Do you do that? Do you do this? And your answer is either yes, no, then it belongs to this section. Your eye color, like what kind of eye color do you have? The brown, the blue, that is also, this, because they're all categorical. During the election, are you voting for Democrat, Republican, the Green, Independents, and all those type of, committee, any kind of party affiliations? So that is also considered as population proportion. So that means it's categorical variables. So we don't find mean here. So when we do this kind of variables, we don't find mean here. We find the proportion. Okay, again, proportion is less. Okay, we find the proportion here. Okay, now so example, we can talk about eye color. So that is the easiest. I think you guys know your eye color, right? So for me is I want to predict what is the North Hennepin the population of North Hennepin students about let's say the brown eye color. So what percentage you think that how the North Hennepin students having brown eye color, for example? Okay, let's say you're interested in this. Okay, so what do I do is I will collect data from you guys. So so I will collect brown, blue. Anyone has another eye color besides brown and blue? Because I'm gonna collect it from I'm sorry. Someone say something. Grace? Grace?
So you're asking what other color?
I mean, anyone in this classroom having different color besides brown or blue?
I mean, it can be green.
Anyone have green? Who has Grace? Are you green?
No.
Okay, anyone? Yep. Black. I just asked because if you don't want to say green, then I don't want. Anyone in the classroom has green eye color? Or hazel, which is kind of green hazel. Anyone has any other in this classroom? Anyone has any other color besides brown or blue? Okay. Can I ask what eye color you guys have? Can you type it in your chat room? Yep, like what Armin did, brown or blue. And if you have other colors, just let me know, because then I will. If you hazel or green, okay. Right. Just go ahead and type it out, and I will start counting. So 1, 2, 3, 4, 5, 6. There you go, hazel. 2 hazel. 7. Thank you for the hazel. Put it down here. Okay, guys, type in already. So I'm gonna count 1 brown, 2 brown, 3, 4, 5, 6, 7 brown. So I got 7 brown eye color in this classroom. And blue, 1, 2 blues and 2 hazels. Anyone still not participating? I got 2 blues and 2 hazels. I should have 14 of you guys. Only got 11. Where's the other 3? Anyone? Where's the other 3 of you guys? Oh, another hazel. Thank you, Skylar. So I'm going to put 3 hazel now. Anyone? Where's the other 2? 12. Yeah, I got 12 students. All right. So another one came out. Brown for Nadia. Now, I just want to point out to you that we have a very small class here. We got only 14 students in this class. So your result is going to be a little bit different from the good result. And the reason for the really good result here, or more what we call accurate result, is because our our sample size is a little bit small. So I'm going to include me because since you only got 14, so I'm brown, so I'm going to put 9 here. So can you guys find me the proportion for this? You guys know how to find proportions? This is what you guys did in my my test. This is called a relative frequency distribution. Remember the word relative frequency distribution? It's very similar to this one. We just call it proportion. So do you guys know how to find the proportion here? For brown, anyone? You take the frequency, how many people have brown, over by what?
So it's 9 divided by 13 times 100.
15 should be,
Oh.
14,
Oh,
right?
it changed. Okay, sorry. I
Yep.
thought I said 13 a while ago.
14, because I put my name, I
okay.
include me. So if
So
you
for
do
brown,
that, yep. Go and do it, 9 divided by 14. You do not need to do 100 because proportion is decimal.
Oh,
So this is around 0.643. Okay, go ahead and then we got 2 of, so for the blue one, you do 2 out of what? 14, right? So this is 0.143. And the last one is 3. So it's 0.214. So this is the proportion that we have. Usually we multiply by 100. As you know, proportion means decimals. We'll leave it in decimals here. So this proportion is what we call as sample proportion. The reason why we call this as a sample proportion is because it comes from the sample. And because sample proportion is a very long word, so we can shortcut it. So we put them a symbol, and that symbol in this case is p hat. Okay, that symbol in this case is what we call as p hat. So so for the brown, the sample proportion is 64.3% or 0.643. The blue is 0.143 and hazel is 0.214. Okay, this is what we have in our classroom. So now we're going to talk about what is all these things here. Okay, so in order for you to estimate a population proportion, you need to have what we call as a point estimate. Okay, what is a point estimate? A point estimate is a single point or single value that it is approximately the population parameter. So we always need where we start from, and we always start from the point estimate. And for the population proportion, the best point estimate for the population proportion is the sample proportion p hat. Okay, so this is how you figure out what is the best point estimate for the population proportion. Is the sample proportion p hat. So for example, if you look at this, if I ask you what is the best point estimate of the population proportion who is having a brown eye color, your answer in this case will be 0.643, because that is the sample proportion of those who are brown eye color. Okay, so can someone, if I ask you, what is the best point estimate for the population proportion, I'm just short form everything, for hazel eye color? So anyone know what is this answer is? What is the best point estimate for the population proportion for the hazel eye color? Based on this table, what is your answer in this case?
Is it just 0.214?
0.214, which is what we call as your p hat. Okay, which is called a sample proportion. Okay, now sometimes in your homework they provide you this, so you can just use 0.214. Sometimes if a question does not provide you the 0.214, they give you in percent, 21.4%, or sometimes it just give you 3 out of 14. So in this case, so there are a few ways for you to calculate this. So either you take 3 out of the total, in this case 14 students, or you take or you divide them and you get 0.214, or in decimals. Okay, so that is what we call as the best point estimate. Okay, so if you read this example in a Pew Research Center research poll, 70% of 1,500 randomly selected adults believe in global warming. So what is the sample proportion p hat in this case? So can someone tell me what is p hat in this case? Forget p hat is a sample proportion. Last time is 0.214 from the Hazel. So anyone? It will be the 70%. So this is your sample proportion, because this is come from the research, from asking 1,500 people.
So you're not actually, like, you wouldn't figure out exactly what the 70% is. The answer would just be 70%.
Yep, because again,
Okay.
proportion is decimals. So we are not asking for how many people, we just asking
Oh, okay.
for proportion. Again, proportion is decimals. So what is the best point estimate of the proportion of all the adults in the United States who believe in global warming? So what will be this one is? Again, to figure out the best point estimates, you use what? Like what we did here. What is the best point estimate? You use the 0.214, right? So what is the best point estimate in this case? It is the same as your p hat. And what is p hat in this case?
0.70.
0.70. Okay, so this is what we call as the best point estimate of the population proportion, which is the same thing as sample proportion, p hat. If a question give you this number percentage, you use that, change to decimals, 0.70. Sometimes they don't give you this number, then you have to divide like what we just did in the one on top. Okay, so there are a couple type of questions, so make sure you read the question carefully. So in order for us to do the estimating, what is an estimation? The estimation in this case consists of what we call as confidence interval. Shortcut for confidence interval is CI. What is a confidence interval? Is an interval that use to estimate the true value of the population parameter. So that means that what we figure out here is we want to find a confidence interval. It's a range. It's like your range of rule of thumb. You have a lower and the upper, right? The lower and the upper. So that is a range or an interval that where we want to estimate where is the true value of the population parameter in this case. So usually in your in confidence interval, there are few forms you can write. So one way is people write it in this way, 0.643 plus minus 0.05, something like this. So you see this quite a lot in when in the newspaper or in your TV. When they do a survey, they always came out this number, 0.643 plus minus 0.05. Can someone tell me, this is a confidence interval. This is considered confidence interval, where if you look at the 0.643, that is actually your p hat. And the plus minus, that number 0.05 or 5% is what we call as the margin of error. So you will learn how to do all this in this class in chapter 7. Short form for margin of error is E. So so in this class, I will teach you how to find the margin of error and how do you do the p hat. The p hat is easy. So if I talk about the confidence interval for the brown eye color, that one is easy to find because we already know what is p hat. Based on this survey I did with you guys, the brown eye color in this case is 0.643. And then the plus minus the 0.05 is this. I will teach you how to find it. We call it as margin of error. But so however that this is usually you can find the lower and upper end for this case. Can someone tell me what is your lower and upper end in this case if you have 0.643 plus minus 0.05? What will be your lower and what your upper in this case?
Do we just add the 0.05 to the 0.643, and then we also subtract the 0.05 from it? So we
That will
add
be-
it. Okay.
So it's very straightforward. So subtract means the lower, plus means upper.
Okay. So
it
the
means
upper is 0.693.
upper is 0.693 and lower
Yeah.
is, so you add 0.05.
Yeah.
0. Subtract that, you get 0.4593, right?
Yep.
So this is what we call as the confidence interval. Okay, that means that when you add and subtract, you got this lower and upper. So that means this interval from 59% to 69% will actually capture the true value of population parameter. So that means that the population for North Hennepin students who having eye brown color is between 59 to 69%. Okay, so it's around this value. Okay, again, we do not know what is the correct one because we don't have time to call 10,000 students. But if I did call 10,000 students and I collect data like what I did here, you got a big number, right? And if I divide it, that is considered the population proportion. That number should be very close to this. Okay, I can also do some online search. So if I just go online search and ask for what is the racial eye color that we have in this world, we're talking about this world, right? So eye color in this world. So if you look at this, it is around 70 to 79% in the whole world. So this is the eye color for brown. So if you look at that and compare it with ours, ours doesn't reach that number, right? Ours is only 59 to 69, but this one says 70 to 79. So so what happened is that the population proportion of those who having brown eye color based on the website that I just pull out here is this. Now, usually we do want a number, we don't want a range. So I just do the middle, the mid range, right in the middle. So 70 plus 7, like midpoint. 70 plus 79, 74.5%. So I would say 74.5% is your so what happens in this case that our confidence interval based on our this class that I collect, it does not capture, it does not estimate the correct, okay, because the correct one is 74.5 and 74.5 is not in this range, right? So so this is what we call as confidence level. We're coming up here. Okay, so what is a confidence level? Confidence level is what we call as the degree of confidence. That means how confident are we with this confidence interval is where the meaning is the probability of the confidence interval actually does contain the population parameter as if you repeat this in a large number of times. So as you know that we only did this only one time, right? I only asked you guys in this classroom, one classroom. So in order for us to have a confidence interval, we always have to do it a large number of times. And the probability of that happens. That means the chance of it happens. Usually we use a 95% confidence interval. If you have a 95% confidence level, then the alpha in this case is a 0.05. This alpha that we have here is what we call as type 1 error. Okay, so I just want to pull out to you guys here. This is called a type 1 error. And type 1 error is different from margin of error. So we got a lot of errors. So, and they all mean different. So this type 1 error comes from the confidence level. So if you have 95%, then the type 1 error alpha is 5%. If you have a 99%, then the type 1 error is 1%. Okay. And the reason why we use this a lot is because if you still remember when we do the significantly high, significantly low, we always say it must be less than or equal to 5%, right? Or in order for you to do that, it must be 5% or less. So that's the reason why that we use that 5% or less, is because that is the type 1 error that we have. So and then some of you ask me, is that fixed? I say yes. In the first 6 chapters, we use 5% is fixed. But now, chapter 7 onwards, we can change that 5% to 10% to 20% to. But if you change to 10%, then the confidence level is going to be 90. Okay. If you change it to 20%, then the confidence level will just 80. And as you know that the less confidence you are, that means you're not confident. Okay, so it's no good. So usually we want to keep this confidence level as high as we can. So usually up in the 90s. 95 is a common one that we use. Sometimes the textbook give you 90. Sometimes the textbook give you 99. Okay. So this is what happens to this confidence interval here, a confidence level. So let's say that the brown, we talk about the brown eye color. The brown eye color that we have in this case, the population, the P for the brown eye color is 74.5%, right? Okay. What is the meaning when I say 95% confidence level? 95% confidence level means that if I repeat this a lot of time, so let's say I pick 100 samples. Okay, I only pick one sample from you guys. 95 of these 100 samples will capture this 74.5%. Okay, only 5 of them will not capture this. Okay, what do I mean by will capture it? So I go and ask another classroom, and that I can still find a confidence interval, and that confidence interval is between, let me draw number 1 here. So we have, this is 60, 70, 80, 90%, and 74.5 is somewhere here, right? Somewhere here, okay? So if I go and go to another class and ask how many of you brown eye colors, and I do the, and then divide by the total, 95 of them will capture it. That means the first one maybe is between 70 to 79. So it's close over there. Okay. Maybe the next, so that will capture 74.5. And then I go and ask another classroom, and the class, I do this, I have to do it a lot of time. And the next classroom is capturing between 65 to 75. Which is, yes, it's still capturing this 74.5. Okay, so I do this 95 times, and this all 95 times when I do it, it's gonna capture around this population proportion 74.5. Okay, so 95 of them will capture this. Okay, but like our classroom, if you look at our classroom, is 59 to 69. So unfortunately, we consider that 5% error for our classroom is because our classroom did not capture it. Our classroom only captured between what, 59 to, so let me erase that. So it's between 59 to 69.3, right? So it's around here. So if I go, so this is what we call as your 5% error here. Your type 1 error, the alpha here, is because our confidence interval that we did is the significantly low in this case. And why I say significantly low, because our number is a bit lower than 74.5. And yes, when I ask another class, sometimes it can be significantly high. It means that this number is above, let's say it's between 78 till 88. Yes, it can happen. So how many of this gonna happen if I collect 100 of them? 5%. So that means you will get 5 of this what we call as the bad ones. Okay. So so this is a meaning of the word 95% confidence level with a 5% error here. Means that if you repeat this 100 times, 95 times of it will capture this value, the population proportion value, and only 5 times will be either way down, significantly low, or way up, significantly high. Okay. So, and yes, I can increase this 95 to a 99%. So if I increase this to a 99%, then 99 out of 100 samples will capture this, and only 1%, in this case, because 99 opposite is 1%, one of these will not capture it. So either that one can be low or significantly low, or the one can be significantly high. So yes, I can change this to 95, 99, and 90%. So now instead of 5% that we use now, it can be changed to 1%, 5%, or 10%, depends on what we call the confidence level. Okay, so the confidence level is always given in the question. Okay, so when you read the question, they always give you find the 95% confidence. So they always give you that number. If this confidence level is not given to us, then we will use 95%. Okay, so this is the one that we use. So this is if the question did not provide, then we use 95%. Okay, this is very common. Okay, we will use. Now, what we do here is once you construct this confidence interval, you need to know how to interpret it. So this is super important. And as you know that you are allowed to use another one page, right, in your finals. So I would recommend you guys to write this one in there, because this is the one that that is very important. So make sure, and this is what we call, don't just write it down, you know what it is. This is called interpreting confidence interval. So if a question wants you to interpret, this is how we interpret. So let's say this is the confidence level that we have. So how do you fill in this? And let's say we use 95%. So we are 95% confident that the interval from 0.593 to 0.693. Again, this two number comes from the confidence interval that we found early on. Actually does contain the true value of the population. Now you have to type it out here. This is talking about population proportion who is having brown eye color. So you have to type. This is how we do our interpretation. Is we are 95% confident that the interval from this to this actually contain the true value of the population proportion who is having brown eye color, because we are talking about brown eye color in this case. So this is how we interpret this confidence interval. You do not need to worry about this interpretation. The one underneath is another way to do it, but we don't do it. So don't, you just need to memorize the first one. Okay, this is how we should do it. In your online homework, they will also use this interpretation that I pick, but they readjust the sentence. So instead of doing we are 95% like this, they just say the true value of the population proportion who is having brown eye color is between the interval of this to that, using a 95% confidence. So what they do is they just do like Spanish. They just change the wording, but it's the same meaning, but they just readjust or rearrange the words. You know what I'm trying to say here, class? So so that means that they just rearrange it in your homework. So I would recommend just stay with this one, because in your online homework they have multiple choice A, B, C, D. So make sure that you have all these keywords, and I will underline or I will underline the keywords that you guys need. The word confidence is, let me just highlight it. The confidence is a very important word. The word true value is important, and the word population is important. And definitely the blanks is important. You need to fill in the blanks here. So beside those blanks you have there to fill in, the one that I highlight in yellow is very important. So like these are the ways that is incorrect ways to do it. There is a 95% chance that the true value of P falls between these numbers. This is wrong. It's because we don't use the word chance on it. Okay, we will use the word confident. Okay, so do not use the word chance, 95% chance. We use 95% confident. Okay, so if you see the word chance, please take it out. And number 2 is wrong. 95% of the sample which will false. We don't use the word sample. We use the word population. Okay, so there are 2 mistakes on the second one. Is one, we don't use the word sample. We use the word population, and you have to put this percent confident. Okay, so you have to put the word this percent confidence of the pot. So there are 2 mistakes on number 2. So in your online homework, if you have a choice, and if you got a choice that have word chance and the word sample came out, please do not put it, or do not pick that. That will be wrong. So make sure you have the word confident, the word population, and the word true value on it. And make sure these numbers match with your confidence interval. So this is how we figure out your confidence interval in this case. Anyone have any questions here? How we interpret and stuff. And I will show you how to get this confidence interval using your StatCrunch. Okay, so you do not need to worry about calculating. So there are 2 ways for you to calculating this margin of error. So the p hat is found by taking, the how many people we have over by the total. So the margin of error E, the 0.05, there are 2 ways for us to find it. Okay, so I will show it to you how to do this one. So and again, one way is the difficult way, where if you go to your online homework and say, help me to solve this, and they will use that way. I will show you that way too. And then another way is using StatCrunch, which is the quickest way to do it. So I will show it to you how to do those in both ways. So so to find the margin of error, okay, we got 2 ways to do it. Okay, one way is the long way. So when I say the long way, means when you have to solve it, you have to figure out what is the critical value, and then after that you have to figure out what is the standard error. And then the margin of error is you take the critical value times the margin of error. Okay, it's a lot of work. Okay, the critical value is you have to use your StatCrunch. You go to normal calculator. Okay, I will show it to you in the notes here. So this is a critical value. So what is a critical value? A critical value is a number that separates the significantly high and the significantly low to the no significant. And in your StatCrunch, you go to the normal calculators where the mean is 0 and the standard is 1, and you take x equals to blank. Don't forget this means blank. Equals to alpha over 2. And don't forget, class, alpha in this case is your confidence, your error, your type 1 error. So your alpha in this case is your type 1 error. Okay, so go ahead, we'll try to do this. So if I'm asking for a 95% confidence interval or level, confidence level, sorry. Confidence. I'm sorry. Yep.
I don't have that on the sheet that you gave us. Can you show us that again?
This one?
Yeah.
You guys don't have this?
Yeah, I have like the finding critical value.
And it's a different one?
Yeah.
Who has a different one beside Casey?
I also don't see the stat crunch.
You
on
have
mine
R on it.
No, I don't see it on mine either.
What do you have in yours for Skylar and Casey?
Mine is finding critical value, and then it says ZA/2 equals Q norm. It
P
has
norm?
that.
Yeah,
Yeah.
that's
Okay.
what mine says too.
Okay, so Casey and Skylar, I will give you please, I will we won't see you guys Wednesday. Can you I will email you this. Can you cancel it off and write this down on it?
Yep.
Beside Casey and Skylar, can someone beside Casey and Skylar, can some of you please check your notes, see if this is the same as the one that I have? Anyone? Beside Casey and Skylar, please check your note. Armin, you got the same one? Oh,
I have what you have on the screen.
okay. Armin has. How about the rest of the group? Anyone who do not have this one? Beside Casey and Skylar.
I have the same to have what you have on the screen.
Okay, so who do not have the same one beside Casey and Skylar? Please talk to me. Okay, I will send you guys Casey and Skylar. I will send you an email with this one on it. So because we don't meet on Wednesday because of COVID. So I will send you this. If you can, either you change it, just write, like, take a pencil or pen, cancel and write on, or print it out. I will give you, you can print it out of this. The rest is also similar because I teach another class. They use a different software, and that's why you get that software. Okay. So for example, in this case, like we are using a 95% confidence level. So if I give you 95% confidence level, what is the type 1 error or alpha in this case?
5%.
0.05. So in this case, yep, you're correct. So in order for you to find the critical value in this case, we need to go through this calculator normals. Okay, so you go to your StatCrunch. And then what you need to do here is you go to stats, calculators, and normal, like the one that we did in chapter 6. So what you do is you put your mean is 0, standard deviation is 1. So 0, 1 already. Make sure you use greater than or equals to. So change this to greater than or equals to. Leave this blank. And alpha, you say, Lawrence says 5%, right? 0.05 over 2. Okay. And the reason why it's over 2 is because you got two sides. One on the left, significantly low, and one is on the right, significantly high. So that's why you have it over 2, because you got two of them. Okay. And when you hit compute, that number that you leave blank is called the critical value, and that will be 1.96. Okay. So that means that the critical value for 0.05 is 1.96. And I'm going to give you plus minus 1.96 is because of you will have two part of it. So the reason why one is a positive 1.96 and one is a negative 1.96. Okay, because we got two of them. So so that means that this is called a 95% confidence interval, where 95% falls in the middle, and then there are 5% that contribute the significantly low and significantly half, and we use it divided by 2. So that's why we use a 5% divided by 2 here. And the reason why we take 5% divided by 2 here is because you got two-sided. So if you do the, that's why this is the same as 0.025. Okay, so this is significantly low, this is significantly high, and in the middle is no significant. And when you do the confidence interval is right in here. So the confidence interval is the low and the upper, right? So that is where the confidence level interval falls based on the 95%. Okay. Yes, we can also change 95% to 99%. So if I change to 99%, then what happened is your alpha is what? Point
1%.
is 1% or 0.01. So what is the critical value in this case is we do the same thing on this. The mean is 0, the standard deviation is 1, you still use greater equals 2. Then this you use 1% divided by 2. Okay, and again we divide by 2 is because you got two-sided. You got one low and one high. So that gives us 2.576. And we use plus minus is because it is two-sided. Okay, so if I want to draw the picture for this 99%, your picture will look very similar to this one. However, your critical value is a little bit far because it is 99% in the middle. And only 1% that contribute to both of this. So in this case, it actually is 0.5%, because half of 1% is 0.5%. And this value is 2.576. One is plus, one is negative. And look at your confidence interval. It's getting bigger. Okay, so this is something that you guys need to know here is if you increase your confidence level from 95 to 99, your confidence interval will get bigger. Okay, because 95 is a little bit smaller here. So once you increase to 99, it's going to be bigger. Okay, so if I ask for a 95% confidence interval, your critical value in this case will be plus minus 1.96, which is this one. Okay, so we use 95% in this case. Okay, what is standard error? Standard error, we have a formula, and that formula is EKI. It's the square root of p hat times q hat over n. So this is what happens, class, when you try to do my homework and say, help me to solve this. They will use this method where they will ask you to find the critical value, and then they want you to figure out the standard error. Now, what is p hat and q hat? P hat is your sample proportion. So let's talk about those who use for the brown eye color. So based on the survey that I did with you guys, the p hat in this case is the sample proportion. That means how many are brown eye color is 0.643. Okay, so this is your p hat, or the what we call as the best point estimate. So does anyone know how to find q hat?
Is it 1 minus 0.643?
Yes, it's 1 minus p hat. So if you take out your calculator and put 1 minus this, that will be your q hat. So go ahead, take 1 minus 0.643, what you get? That will be 0.357. So what is p hat and q hat here stands for? P hat in this case, it means those who are brown eye color, right? We're talking about brown eye color. What is q hat in this case? Are those who are not brown eye color. So the word, the q in this case is the what we call as the complement, means not of that color. Okay. So like example, if p hat is female, then q hat will be male, which is not female in this case. So, and every time we find q hat is 1 minusing it. Okay. And the last thing we need to know is n. What is n in this case? Is n is your sample size. So if you look at my survey, I got how many students I collect. I got 14, right? 9 plus 2 plus 3. So I got 14 students here. So if you put this in your calculator, the square root of 0.643 times Q hat 0.357. And you divide this by 14. We got 14 students. I surveyed 14 of you, including me. And you take the square root of it. This is called the standard error. Well, this is I will only show you this time because this is not the way I'm supposed to teach you. But if you guys are using your online homework and try to help me to solve this, this is what you're gonna do here. So this number is going to be 0.128. So if you want to find the margin of error, you take the critical value, which is 1.96, times the standard error, not the MOE, the standard error. So the MOE standard error. And the standard error in this case is the 0.128. So that will give me, take this times 1.96, 0.251. So this is how you find your margin of error the long way. Do you guys like it that way? No one like it, right?
No.
You had to figure out this. You had to figure out this, and then you multiply it. So if I want you to figure out the confidence interval for this brown eye color is P hat plus minus E. And P hat in this case is the one that having brown, 0.643 plus minus 0.251. So this is how you find the confidence interval. And I would not recommend you guys to do this. You can do it, it's not wrong. You guys okay here? And this is how your computer shows you how to solve this. You can be my guest, okay? I'm gonna show you the shortcut way. And your computer will not show you this way. They will show you this wrong. Yes, it's okay to do it. Okay. So now I show you what is the shortcut here. Okay, so this is what happens here. We just talked about that in just now. So so it's all in your notes here. So in order for you to find the margin of error E, you have to multiply the critical value with the standard error. That's why we did it over here. We take the critical value and we multiply with the standard error. That is the margin of error. And the definition of margin of error is given here, is the maximum of likely difference or maximum probability that an observed sample statistic between the observed sample statistics with the population parameter. So so this is the definitions of margin of error. So how wide, what is the biggest maximum we have? As you know that we did not, again, use this way to find it. We will use the StatCrunch. So we won't use this way. So I will X it up. So this is the long way that, so I will X this one out. See, this is a long way to figure out. Okay, so this is a long way. So we do not want you to, I do not want you to, if you can, if you, I really suggest not to do it. What is the shortcut way? So in order for you to do the shortcut way, you use the StatCrunch. So you go to stat, proportion stat, one sample with sum. So this is what you need to put in stat in your StatCrunch, stat, proportion stat. And when you put this in there, they will ask you for two things. They will ask you for three things actually. They will ask you for X, X in this case is called the number of success. Okay, so in this as if you look at this example, X in this case is 9. Why I say 9 in this case is because 9 is brown. You see that the 9 brown. So for this example, 9x in this case is 9 because that is the number of students who is brown eye color. This is for brown eye color. Okay, so this is the number of success. And you also need to know n. N in this case is sample size. That means how many students or how many people we survey. So in this case, we got 14 in this because there are 14 students, total number of students. Okay, and then in your StatCrunch, they also give you one thing. They call it the confidence level. So the confidence level in this case, we will use 0.95.
I have a question. So that n equals sample size, there's a difference between a small n and a big N, right?
Yeah, this is all using small n.
Okay, I
Because
have the big
N.
N.
Yeah, change it to small n.
Okay.
Okay, so those who have Casey and Skylar, because I know yours is small n, change it to big N. A small n, sorry. So please change it to small n. It's a typo. And so what you do here is you go to your, so in your shortcut way is you go to StatCrunch. You go to this, you go to stat, proportion stat. You go to one sample with summary. Can you guys go in there in your StatCrunch with summary? And you have to type in your X is 9, your N is 14, and your confidence level is 0.95. So I show it to you here. So we don't use that anymore. So we will be using stats, proportion stats, one sample with summary. You guys found it? You guys, this is what it looks like. So the number of success is X. So that is 9. We got 9 brown eye color in my classroom. Number of observation, that is the sample size, 14. You do not perform hypothesis testing. You just click down here. You are doing confidence interval. And just the level in this case is 0.95 and just use the standard board. Okay. We don't use the other one, so just use this. And you just hit compute. So what you guys need to do is number of success is 9, number of observations 14. We got 14 students here, 9 having brown, and then the 95% is the confidence interval. So when you hit compute, this is what you get. We are concentrating on the lower and the upper limit. So so don't look at the rest. I mean, that is important, but we're looking for lower and upper limit here. So your confidence interval in this case is your lower and your upper limit. So what is lower in this case is 0.39192, somewhere around there. And my upper is 0.894. You guys see that? So this is a confidence interval, but wait a minute. If you look at this one, yeah, this is your answer. How you find margin of error? So how do you find MOE? Okay, now your MOE is not 0.128. Oh, standard error. Oh yeah, standard error. Looks like my MOE 0.128. No, it's not. It's not point this one. So how do you find your margin of error if I give you the lower and upper? You just subtract these two and divide by 2. Let me repeat. In order for you to find your MOE, you just take the upper minus the lower and divide it by 2. So who has calculator? You help me with this. Subtract these 2 and divide by 2. What do you get? So this is formula is important.
I got 0.251.
Yes. Which is exactly the same as him. See that? How about p hat? Okay. Because this is the same as this one, right? 0.251. So in order for us to find p hat, it's very easy. You instead of subtract, you add. So you take the upper plus the lower divided by 2. So it's very similar to this one, 0.894 plus 0.392 divided by 2. And you should came up to be this answer. You guys got 0.643? Which is this answer, right? So now, which one is easier to do? Which one is easier for you guys? This one, the shortcut, or the long way to do it? Definitely the shortcut, right? Okay. So make sure you guys, I do not suggest you to do the long way. You can. I didn't say you cannot do it. I don't suggest you to do it. Otherwise, you have to memorize this formula and you have to memorize the critical value. Beautiful. It's a lot of work. Okay. That's why we do it this way, which is quicker. Okay. So your confidence interval is this, or if I want to write it, p hat plus minus e. In this case, will be 0.643 plus minus 0.0254. So that is very similar to what you did here, but the work is definitely cut short. Questions?
Could you please build the StatCrunch one more time? I think I missed it.
So what you do here is you go to stats, you go to proportion stats, one sample with summary.
Okay.
The number of success is how many got brown eye color. So based on the survey that you guys do, 9 of you having brown eye color and 14 of you in the whole class. Okay. And we will click down to confidence interval and we are using a 95%. So you put 0.95 and you hit compute. And the last two numbers is the lower and upper limit. You got it, Suli?
Yeah.
Okay. So this is how you do your the confidence interval the shortcut way, which I will, will definitely suggest you to do it. Okay. So this is right over here. Okay. Now let's fill in some other notation. So this n, the number of success, x, the sample size n. I'll just change this to something else because your text, your number of observation, because your StatCrunch is using different words. So I'm going to use number of observations. So it's the same. So n is the number of observations, which is the same thing as sample size. And then make sure the confidence level can be 0.95, can be 0.90, can be 0.99, or can be 0.92. This is, make sure you guys know, when I ask for percent, don't put in this percent, put it in the in decimal place. Okay. We got a few more notation here. P in this case is the population proportion. Okay. And P hat is called the sample proportion. Okay, which is called the best point estimate too. So if a question is asking for best point estimate, we are doing p hat here. And if a question provide you the p hat, usually it is in percent, like 70%, like what we did last time of the people. If a question didn't provide us the percent, then you take x over n. Okay, so you can find this by taking x over n, where x in this case is the number of success, n in this case is the number of observation. So like last time we got 9 brown eye color over by 14 total students, so 9 over 14. E is a short form for margin of error. And in order for you to find the margin of error, you take the upper limit minus the lower limits and you divide by 2. Okay, like what we did over on this example here. So to find the margin of error, you take the upper minus lower divided by 2. And this z alpha over 2 is called a critical value. Okay, it's called a critical value. And in order for you to find the critical value, you use the normal calculator. That's what you guys studied in chapter 6. Okay. So this is your little notations here. Now, in order for us to use this proportion step 1 sample with summary, there are 3 requirements you have to fulfill. If you did not fulfill one of these requirements, it's no good. One of the requirements says it has to be a simple random sample. This simple random sample is usually found in the question. The word random is there. So you have to, this is in the question, you have to find like a, and the word random has to be in there. So if you don't see the word random in there, means it is not simple random sample. So please read the question really carefully and make sure you like circle or underline the word random. That is the meaning of a simple random sample. Okay. The next requirement says it has to be a binomial distribution. So a binomial distribution has 4 conditions. It has to know n. So that's why you got n, we know n. The trial has to be independent. So like eye color, if I ask you what eye color, Lawrence say his brown eye color. Casey's answer does not depend on Lawrence, right? Casey's eye color is on her own, right? You say, oh, because Lawrence is brown, my eye color is also brown, right? It's not that case. So it's independent in this case. You got 2 category outcomes. That's called a binomial. Means either you are brown eye color. If I talk about brown, so either you are brown or you're not brown. Okay, we're not talking about brown, blue, and hazel because that's 3, right? So we only concentrate on 1, brown. Then it's a binomial because it's either brown or not brown. And the probability is the same for each trial. That means when a new student came in, let's say David came in, I do not know what his eye color is. So I will say his eye color for brown and not brown is 50-50. I do not know, right? It's 50-50 chance you get brown or not brown. And let's say another student came in. And if I want to guess what is the probability of this student's eye brown color, I will just say 50-50 because I do know, because there's 50-50 chance of getting brown and not brown. So that means that the probability is the same throughout the whole time. So this is the second requirement. And the third requirement says it has to be at least 5 success and it has to be at least 5 failures. So what is 5 success and 5 failures in this case is, if you look at this question, the success in this case is the how many brown eye colors we have. So that is your X. So we know that in this case, we got 9 brown eye color. So that is at least 5. Again, at least means that number up, 5 plus. So this is good. So can someone tell me how many students has not brown eye color? Anyone figure out?
5.
How do you get 5?
14 minus 5. 14 minus
So
9.
we got 14 students, if 9 of them is brown, then 5 of them is not brown. Because the total of this should be what?
14.
14, because we have 14 students. And since if you look at this, 9 is at least 5. 5 is also at least 5. So at least 5 means 5 and more. So that means this condition is fulfilled. Because we got 5 students who have not brown eye color, which is good. And the binomial is also fulfilled. But unfortunately, the random does not fulfill. When I call you guys to put in what is your eye color, that is not random. If I say random, I will call a computer to generate like 10 students. I'll say, all right, the first name came out is Skylar. Then I would just say, Skylar, what's your eye color? So that is random. But if every student is included in this survey, it is not random anymore. So so make sure. So if it's one of this is no good, you cannot use the proportion stats. And the other thing that we found out that this margin of error is, so remember you find the margin of error here. This margin of error is super huge. This is 25.1%. This is super big. Okay, so usually we don't use this big margin of error. Usually margin error is small, like 4%, 3%, 5%. If you got a 25% like what we have here, that is one thing that you will get this super big. The reason why you get this huge MOE, margin of error, anyone know why we got this big number? Why this is super big? Casey?
You did something wrong.
No, I didn't do something wrong. It's everything is right. Your sample size is too small. How many students you pick? We only got how many students? We only
10.
got 14 students. Yes, if you have a very small sample size like 14 or 15 or 20 students, your margin of error is going to be super big, like 25%. So in order for us to lower this below 25 to 5 or 4 or 3%, then your N has to be increased. So that means I have to pick more than 14 students. I have to pick like 300 students. So when you pick a big sample, like 300, 400, 500 students, then your margin of error will get smaller. You won't get 25%. It's going to be down to 5, 4%. Okay. So once you see a 25% in your margin of error, please do not even look at it because the result is no good. It's biased or it's something wrong. And one of the reason is the sample size. You look at how big is your N. If your N is way too small, like 14, that's the reason why that you get a big one, a big margin of error. Okay, you will see some examples what is going on. Okay, so how many ways can we write your answer? You can write your answer in 3 ways. Your StatCrunch will give you this answer, lower and upper. So this is what StatCrunch will provide to you. So this is what StatCrunch will do. I put SC for StatCrunch. Okay, so your StatCrunch will do this way, the P hat minus E, P hat plus E. There is also another way to do it, is finding P hat plus minus E, which is the one that we just did over here. This is also another way to do it. Okay, so this is method number 1. This is method number 2. And the third way to write your answer is just taking the lower 0.9392 is less than or equals to P is less than or equals to 0.894. So there are 3 ways to write your answer here. One way is just straight away from your StatCrunch. The other way, you have to figure out your margin of error and your P hat, and then you write it this way. And the last way is to just take the lower and the upper and take 0.392 is less than or equals to P is less than or equals to 0.894. So this is a third way to do it. So in my test, I do not care which way you write your answer. because I will recommend you to write your answer like this, because it's already in a StatCrunch. You do not need to find all this stuff. However, if your online homework, if they specifically want you to write either this way or the other second way, then you have to find the p hat and the e, especially for the second way. Okay. The third way is easy. You just put this is less than or equals to p is less than or equals to 0.894. So that is all the three ways, which is right here. Okay. I would suggest you to use this way unless it is specific as in the question. Okay. For my test, I don't ask. I will ask for this way actually. Okay. You can write another way, fine with it. And this formula is the one that I just showed it to you. So in order for you to find the p hat, you take the upper plus the lower divided by 2. If you want to find the e, you need to take the upper minus the lower divided by 2, so which is the same formula as this 2. Okay, so I put a checkpoint on it, means that you need to know this. Okay. So this is the 7.1. We call the margin finding estimation of we call it confidence interval. So now if you look at this example, if I give you this confidence interval between 0.179 and 0.321, can you guys figure out to write this in the form of p hat plus minus e? That means you have to use the formula on top here. So go ahead, use your formula on top to find p hat and to find e. Yep. So use that exactly like you have here. This is your upper. This is your lower. So find p hat. Upper plus lower divided by 2. And then the e is upper minus lower divided by 2. So you take 0.321 plus 0.179, add them up and divide by 2. Anyone got a p hat in this case?
P here is 0.25.
You guys okay with that one? Okay, that's correct. And for the margin of error, you just need to take the upper and lower, subtract them, and then divide it by 2. That would be 0.
That's 0.071.
So now you just need to put it in your answer. So the form of p hat plus minus e, your answer will be p hat is 0.25 plus minus 0.071. Okay, so p hat is 0.25 and your margin of error is 0.07 in this case. So it's not bad, 7.1%. It's better than 25% that we have in our classroom. Okay, so I think the first few questions in your 7.11 homework is calling you to do this way, where they give you they want you to figure out what's p hat and e using this one. Okay. Anyone have any questions for me so far? Next, question 2. I want you guys to read question 2. And I want you guys to, you got your paper, so underline or highlight the important information. Yep, I'm also taking attendance. Thank you, Suli. Please, attendance, please. Yep, thank you. So read question 2 and figure out where is your important. Can someone tell me what is important things in number 2, question 2? Make sure you
Randomly.
Very good. Randomly selected. So that is very important. So please make sure you guys circle or highlight or underline. This is what you do in my test because it's all going to be like this. You have to read and learn. What else is important? The numbers. 1, 2, 2, 8 is important. And also what? 8, 5, 6 is important. Can someone tell me what is 1228 stands for? Is that stands for N, X, or confidence level?
It's N.
Okay, so this is how many people we survey or how many we study here. So that is your N. So in this case, N is 1228. And what is 856 in this case stands for? That is your X in this case. Okay, so that means 856 people are dropped. So that is called a number of success. So sometimes the question gives you these two numbers, and I want to point out, the students ask me, your N in this case is always greater than X. Okay, some students ask me, is the N always bigger than X? The answer is yes. So if you switch around, if this is your N and this is your X, you will get it wrong. I will say you got 856 students and 1,000 of them are brown eye color. It's like, how does that happen? You only got 800 students. How can you get 1,000 people is brown, right? So weird, right? So usually the big one is the N, the smaller one is the X. Okay.
Hello, Prof.
Mm-hmm.
Yeah, if you look at the question too, you could decide that this is 856 is X because it was the number of people that you know involved in malpractice, medical malpractice, right?
Mm-hmm. Yep. That is why that is the out of this 1228, this is how many people that got the lawsuit got dropped.
Dropped, yeah. They didn't involve in any medical malpractice.
Yep. So this is called a success.
Yeah.
So can someone tell me how you figure out your failure?
So that's going to be 1228 minus 856.
Yes. So you have to take the N minus the how many successes we have, 856. Anyone has a calculator? Help me with this. And you have to better calculate this too because how many cases?
372.
372. Yep. Thank you so much. The reason I want you to do this is because of the first 2A. 2A is asking you to figure out the requirements for this case. Okay. So how do you do this in my test? If I ask you for the requirements check, we call this as a requirement check. And if you look at this, the requirement check is this 1, 2, and 3. These are the 3 requirements. So the first requirement check we have is a simple random sample. Now, if you have time, you type simple random sample because we don't have time, so we just use SRS. Okay, so because in your test, if you I will suggest you you can use SRS. SRS in this case means simple random sample, and how do we know to answer yes in this case? Is the word randomly selected. Okay, so if your question has the word randomly selected, then it's yes. What happens if your question do not have the word randomly selected? Can you assume it is randomly selected? The answer is no. Okay, so if there is no randomly selected in the questions, then this requirement, first requirement, does not fulfill. Okay, the next one is a binomial. Binomial has 4. First, we need to know N. N is no 1, 2, 2, 8. Second is independent. As you know that when you bring a lawsuit to a court, all lawsuits are treated independently, means that they don't depend on your previous lawsuit. Okay, so they're all treated independently. 3, you got 2 outcomes. Yes, either you bring it, either the lawsuit is guilty or not innocent, not guilty, or in this case, drop or not drop. And the 4th one is the probability is the same. So when you bring a lawsuit to the court, if I'm the judge, without giving me the evidence, I will say, what's the probability of this is guilty and not guilty? I will say 50-50. And then you bring another lawsuit. still 50-50. So they are the same. Okay. So until you give me all the evidence and everything, then then I have to judge. So so in this case, your binomial will meet. And the third one says that your success has to be 5+, and your failure also has to be 5+. 5+ means that 5 or more. So in this case, it will be yes too, because if you look at the success, we got 856, which is more than 5 more. And failure is 372, which is also 5+. So in this case, this is how we check the requirements. So in this case, the requirement is fulfilled. Okay, so this is how you do in my test, and in usually my test is that fulfilled or not. Now, what happens if one of these does not fulfill? Then the requirements do not fulfill. So for my homework and for my test, you are still going to continue doing B, C, D, E, F, whatever they have there. Okay, so because you are still studying this class, so you do not know what is the behind the stories. So that's why even though you do not fulfill the requirements, you still have to continue using the StatCrunch. However, if you are doing your project, your research, your thesis, your thing that you study, then you cannot do it. Okay, you cannot use the StatCrunch like what I teach you here. The reason why is because it's a little bit different, because they are doing research where you have to present it. This is because you're just learning from my class. If you learn more statistic class, then you will know what kind of test you do. Okay, so right now, if you're not fulfill the requirements, you still need to continue doing the rest of it. Question B is asking for best point estimate. Does everyone remember the beginning of class, we talked about best point estimate? What is the best point estimate? Like last time, if you remember, the 70% is the best point estimate, right? Or if you talk about Hazel, is what? 0.214 is the best point estimate. And how do I find this number? I take this X over by the total, right? So can someone tell me what is the best point estimate for this question B? So the symbol we use is called a p hat. The little thing on top is called a hat. So how do you find this? Is you take X over N. So how many cases is drop or dismiss, success in this case? 856. And how many total cases we have? 1,228. So take out your calculator and figure this one out. And this is what we call as the best point estimate. Do not change it to percent, just give it to me in decimals. So that will give me 0.697. Okay, use your calculator. And this is what we call as best point estimate. Questions here?
Is that the same thing as p hat?
Yeah, this is p hat. Yeah. Yep, best point estimate is p hat. And this is how you calculate p hat. For part C, you have to find a 99% confidence interval. So how do we find 99% confidence interval? Is you have to go to StatCrunch. Oops, sorry. You have to go to StatCrunch. You have to go to the stat. You have to go to the proportion stats, one sample with summary. So can someone tell me what do you need to enter in your number of success here?
Isn't that the 856?
Because that's how many people is drop. And number of observations?
1228.
And make sure you go down to confidence interval and what confidence level they ask you to find.
99%.
99%. So in decimal is 0.99. You guys with me here? Okay. So and then you hit compute. So what you need to do here for me is you just need to, in this C, you just need to tell, if you didn't write all this in your test, you write down number of success is 856. Number of observation is 12228, and the level is 0.99. And then the results, and you just need to look at your result. Anyone got a result here? You get this? 0.663 and what? Followed by what? 0.731. So this is the result that you get. The 0.663 is a lower, upper is 0.731. You do not need to do the P hat and the E, the one that we just do on number 1. You do not need to do it. This is what you need to do in my test. Type in the number, what is the number of success? Okay. And don't forget, this question wants us to interpret too. So how do we interpret this confidence interval? The interpretation is the one that I want. This is the interpretation. We are 95% confidence interval. Blah, blah, blah. So this is the interpretation that we want you to write down. So the interpretation in this case is we are 99% because we are 99 confident. Don't use the word chance that the interval from what is interval here? 0.663 to 0.731 capture the true value of the population proportion. Now, if you want to figure out what is this population proportion is, you just read the question. The question is asking us to find the 99% confidence interval for the population proportion of malpractice that is lawsuit abroad. So that means that is the one that you need to put in now. Population proportion of medical malpractice. So you just copy and paste it. Lawsuits that are dropped or dismissed. Okay. So this is how we interpret your confidence interval, which is the one that I showed to you on the first page of your notes. And this is very important. D. D is asking us to write this in the form of this and the form of that. So this form is very easy because we know the lower and upper. So you just take 0.663 is less than P is less than 0.731. So this is form number 1. In order for you to do form number 2, you have to repeat like what you did on the first question. This is your lower, this is your upper. So you have to find your P hat first. And how do you find your P hat is you take the upper 0.731 plus the lower 0.663, add up and divide by 2. And then you find the margin of error, which is 0.731 upper minus the lower divided by 2. So that is how it's very similar to number 1 that you guys did here. So you need calculators to do this work. So 0.731 plus 0.663 divided by 2. So you get 0.697. And you find out that this number is the same as part B. Okay, because look at the P hat, that should be the same, right? Which is 0.697. For this margin of error, you just take 0.731 minus 0.663, and then you divide this by 2. So it's 0.034. So if you want to write in the form of P hat plus minus E, then your answer is 0.697 plus minus 0.034. So this is your the other form. You want to have any questions? Okay. The last one we're going to do is part E. So for part E, we will be doing what we call as majority. Does it appear that majority of suits are dropped or dismissed? Does anyone know what's the meaning of the word majority? Anyone know the meaning of the word majority?
Like more?
More than what percent?
More than 50.
Okay, so yes, majority in this case means that it is more than 50%. Okay, and how do we figure out if they are majority? Is you look at the result here, your confidence interval. Is this number is more than 50%? Yes or no?
Yes.
66% is more than 50%, and 73% is what, more than 50%. So in this case, your answer is yes. Majority of the lawsuits is dropped or dismissed because the confidence interval is above 50%. Okay. You can tell that because 66 and 73 is bigger than 50%. So that is called a majority. Okay. So I want to point out to you guys that, okay, so 50% is right here. So if your confidence interval is somewhere over here, this is called majority. Okay. If your confidence interval is somewhere on this side, we call this as minority. Anything less than 50%. But what? So that's why our confidence interval that we found here is 60-some% to 70-some%. So it is majority. Okay. And your confidence interval fall between like 20 to 40%. That is called minority. But what happens if your confidence interval fall in between 50, somewhere around 40 to 60, so somewhere around here? Okay. Then the answer is this is not majority. And it is also not minority. Okay. So if you have your confidence interval get exactly 50, then we say that they are the same or equal. Okay. In other words, they are not majority, they are not minority. If you go above it, majority. If you go below it, minority. If you get in between the 50%, then it is the same. In this case, we call it they are the same. That means the lawsuit that is dismissed and not dismissed are the same case. You will learn more about this in my Wednesday class because you're just learning this. So we're gonna stop here. So I will post these notes in D2L also together with the videos today. So please watch it. So those students who are who doesn't know this, please go and watch the notes and the videos and everything in D2L. So you will get the answer here. And class, please do not do the long way, do the shortcut. Okay, because in chapter 9, the margin of error that you see, the standard error that you did see here is not as easy as this. It's very complicated. Okay, so I would recommend you guys to please do the shortcut here. All right, so that's the end for today's class. So make sure you do, if you have any questions, please stay back. If you don't have questions, you may go. And we meet Zoom on Wednesday, not in class.